Hey guys, we are factoring today, and there are a bunch of ways to factor. You've probably been learning them. But in this video, we are looking at a specific type of factoring, and it is called the sum or difference of two cubes. We can use this strategy when we notice we have two terms being either added or subtracted together, and they are both perfect cubes. Now, if you're like, I don't remember what a perfect cube is, guess what? We're going to do a super quick review. So you're probably pretty familiar with square roots. Like the square root of 16 is 4. And why is that? Because when I do a square root, it's asking me what number multiplied by itself will give me 16. So because 4 times 4 is 16, the square root of 16 is 4, right? Now, cubed root is really the same thing. We are just asking, you probably guessed it, what number multiplied by itself 3 times will give me the number that's over here. We put a little 3 to signify that. So for example, the square root of 125 would be 5. And that's because 5 times 5 times 5 times itself 3 times is 125. So as you can probably imagine, there are a lot of numbers that do not have a pretty cubed root. You're going to get an ugly, nasty decimal. So a perfect cube is when we get a nice integer for our answer, like 5 or 10 or 4, right? So that is what a perfect cube is. So when I know I'm going to be working with problems like this, I tend to like to write them out so that I just have these ones right here that I know are perfect cubes. Now, as you work with problems like this more, you will start to recognize these numbers just right off, but I like to have them written out just to help me. All right, now let's go ahead and look at a problem. All right, so let's put this information to use. I would use this strategy if I was factoring and I noticed that I had two terms being added or subtracted and they're both perfect cubes. So let's see if these problems fit that category. So we are looking at a difference here. So I'm looking at this one. I want it to be a term cubed minus a term cubed. Well, we have a term cubed and then we have b cubed, but what about 125? That's not cubed. So this is when I can check and see, is that a perfect cube? I can check my list and look at 5 cubed is 125. So let's see how I can rewrite this to look more like this. So I can have a cubed minus, remember we figured out that 125 is the same as 5 cubed. So I can write this as 5 cubed, right? But then I also have the b cubed. And instead of writing it like that, I can write it like that. All right. So I'm going to write this as 5b cubed. So if I want to check really fast, is 5b times 5b times 5b going to give me 125b cubed? It is. So there we go. I've rewritten it to look like this. So now I can factor it using my difference of two cubes. So when we do this, our x and y are here. This is my x, the first term. This is my y. I also sometimes like to write it over here. X equals a and y equals 5b. All right, now let's see what we can do here. So I'm going to have x minus y, or a minus 5b, times x squared, so a squared, plus x times y, so a times 5b. So I'm going to write that as 5ab plus y squared. Now y is 5b. And if I am squaring that or doing 5b times 5b, 5 times 5 is 25 and b times b is b squared. So plus 25b squared. Woohoo! There we go. We are factored. Now you can always multiply that and make sure that when you multiply it, you get this. One other thing I should have mentioned at the beginning is whenever we are factoring, we want to make sure we check for a greatest common factor that can be pulled out. This one does not have one, but if you need a review on that, I'll link it in the corner for you. All right, let's do one more. This one is a sum of 2 cubes. So let's see if we can rewrite this to look more like that. So I've got my g cubed, that's good. H is cubed, but can 216 be written as a cubed number? Guess what? It's a YouTube video, so yes, it can. 6 cubed is 216. So that means I can rewrite this as g cubed plus, remember, 216 can be written as 6 cubed. And then we also have the h cubed, or we can just write that as 6h cubed, like that. So 6h cubed. All right, now we've got our g and 6h are our x and y. So on this one, x is g and y is 6h. All right, so x plus y, or in this case, g plus 6h, times x squared, so g squared, minus x times y, so g times 6h, and I'm going to write it as 6gh, all right, plus y squared, so plus 6h squared would be like this, which is the same as 6h times 6h, which would give me 36h squared. All right, 36h squared. There we go. All right, that is my answer. You can always multiply it out to make sure you get that when it's multiplied. All right, I hope this was helpful. I will link some more videos because sometimes these ones were pretty obvious, but sometimes we've got like 9 as an exponent or multiple variables. Anyways, if you need some more complicated examples, I will link those for you. Thanks.